This video corresponds to section 6.5 in the textbook. The main ideas we will discuss are solving linear inequalities and then describing the solution sets in writing and also on a graph. Alright, so to begin with, we can build on some previous knowledge from solving linear equations. So we have some properties for inequalities that are similar to those for equations, and then we have one significant difference. So first of all, the property that's similar is the addition and subtraction property. So just as with equations, you can add or subtract the same number from both sides of an inequality. So for instance, let's say we have x is less than 3, then I can add maybe 5 to both sides, and it would be true that x plus 5 is less than 3 plus 5, or 8. And then this rule would be true for other inequality symbols as well. So let's say we have, how about 3x plus 4 is greater than or equal to 6. Well, then I can subtract 4 from both sides of the inequality, and then it would also be true that 3x is greater than or equal to 2. So you can see in this second example why this property is useful. This is the one that lets us move things that are added or subtracted to the side with the variable, move them over to the other side. What about multiplying and dividing? Does that still work? Well, let's look at an example. Here's an inequality that we already know is true. We know that 3 is less than 5. All right, so if we try multiplying, maybe we do times 2. So then we would get 6 is less than 10. Okay? And notice that that is true. All right, what about dividing? What if we do, how about 14 is less than 20? And let's say I divide by 2. So then we would have 7 is less than 10, and that is a true statement. Okay, so at least in those two cases it seemed to work. Let's try a few more. So let's say I have 3 is less than 5, and I decide to multiply by negative 2. So now we would have negative 6 is less than negative 10. Well, picture a number line if you need to, but this is not a true statement. Right, so negative 6 is actually greater than negative 10. And then if we try dividing, let's do 14 is less than 20, and I'll try dividing by negative 2. So now we would get negative 7 is less than negative 10, and that's false. Okay, I ran out of room there. I'll just write an F for false. So the true statement would actually be that negative 7 is greater than negative 10. So this leads to an additional property. If you're multiplying or dividing by a positive number, then it does not change the solution set. So in other words, you can multiply or divide both sides of an inequality by a positive number. Okay, so times or divide by a positive. On the other hand, for negative numbers, when you multiply or divide by those, then the direction of the inequality symbol needs to be reversed to keep that a true statement. Right? So we'll look at one more example. If you have, let's do a negative one. So if you have negative 2 is greater than negative 5, and let's say you decide to multiply by negative 2, then you would get positive 4 and positive 10, and you need to reverse the inequality symbol to keep that a true statement. All right, so if we summarize all of these properties, when you're solving linear inequalities, you would do everything exactly the same way that you would a linear equation, with the one exception that when you multiply or divide by a negative number, you must reverse the inequality symbol. Okay, so with those properties, we'll move forward and do some examples of solving inequalities. All right, so let's start with 5x minus 9 is greater than or equal to 21. All right, so if you just proceed as you would with a linear equation, the first thing you would do is add 9 to both sides. And then you would get 5x is greater than or equal to 30. And then next you would divide both sides by 5, and you would get x is greater than or equal to 6. Okay, so the solution set, we'll write this using set builder notation, and you would have the set of all x such that x is greater than or equal to 6, and you just copy in whatever the final inequality is that you ended up with. And then if we did a graph for this, we're going to do all of these graphs on number lines for now, since we're just dealing with one variable. So you would draw a number line. I know there needs to be a 6 on it, and I would do a few numbers on either side. And then x is greater than or equal to 6, so it could actually equal 6, so a closed circle on 6, and then greater than 6 would be everything to the right. All right. I do want to talk about checking these. We won't do this every time, but this would be a good one to just try checking at least once. So it's a little harder to check inequalities. There are two things that you need to check. First of all, do we have the right number here? Is this 6 correct? And then we also need to know, is this inequality symbol correct as well? So the first thing we can do is check, do we have the x equals 6 part correct? So to do that, you would plug 6 into the equation, or the inequality. All right, so I'm going to substitute 6 in place of x. And then this time I need to make sure that that the two sides of the inequality equal each other. So you've got 30 minus 9 and 21, and that checks out. Okay, so you do want to end up with 21 equals 21 when x equals 6. Then the other part of the check is to decide if you have the right inequality symbol. Should it be greater than, or should it be less than? So you would probably look at your graph, which I just erased, but we had this shaded to the right of 6. So what you would want to do is choose something over to the right of 6 in that shading. So maybe I'll choose 8, and you want to substitute that in to the inequality, and this time you want to make sure that that it makes this statement true with the inequality, the greater than or less than part of the symbol. Okay, so we would plug in 8, and then we get 40 minus 9, and that's 31 is greater than or equal to 21. And you want to make sure that that's true. So 31 is greater than 21, so that does work. All right, so in this case, maybe you're used to seeing checks where the two numbers actually equal each other on both sides of the equation, but for inequalities, that doesn't necessarily have to be the case. They'll only equal each other if you're dealing with sort of this boundary number, whatever number you got in your final solution. All right, let's try another one. 16 minus 3x is greater than 40. All right, so I would start with subtracting 16, and we get negative 3x is greater than 24. And then next you would divide by negative 3, and that should be a warning sign anytime you multiply or divide by a negative. So I'm going to put some stars here. Okay, make a note of that. And then I would do this right away. That tells me to reverse the inequality symbol, so I would do that part first. Okay. And then go back and figure out what the number should be on either side. So on the left we would end up with x, and on the right you would have negative 8. All right, so the solution set would be the set of all x such that x is less than negative 8. And then a graph. So we'll plot negative 8 and some numbers on either side. And then x cannot equal negative 8, so we do an open circle there. And then we want everything less than that, so that would be numbers to the left. All right. We'll try another one, so we'll just do a few more. And we're adding in an extra step with distributing and combining like terms in this one. So we want to solve 4 times the sum of x plus 3 is less than 2x minus 26. All right, so you have some options here. We could start combining like terms. We could move things side to side, but I'm just going to try to distribute first. I'll start there. So on the left we would end up with 4x plus 12, and the right would stay the same. All right, so I usually like to do this so that the x's are on the left, but you could also move things so that the x's are on the right. So let me show you both ways. So first of all, if you shift the x's to the left, you would subtract 2x to try to combine like terms. So you get 2x plus 12 is less than negative 26. And then I would shift the 12 to the right by subtracting, and then you get 2x is less than negative 38. And then when you divide by positive 2, the inequality stays the same direction, so you would get x is less than negative 19. All right, so that's one option. Now I'm going to back up, and let's say we moved the x's to the right. So sometimes you'll do that if that ends up with getting a positive x on the right, so that may be why you would choose to do it this way. So now you have 12 is less than negative 2x minus 26, and then let's say you add 26 to both sides, so then you would get 38 is less than negative 2x, and now when you divide by a negative, now the inequality sign reverses, so it would become a greater than symbol, and you would have negative 19 is greater than positive x. Okay? And notice those two are just saying the same thing. Okay? So the first inequality is saying that x is the smaller thing, and the second inequality is saying that negative 19 is the larger thing. So those are compatible facts. And then you can reverse entire inequalities. Okay, so to switch this second one around so that the x is on the left, you would also switch around the inequality symbol so that it's still pointing towards the correct thing. Okay, it was pointing towards the x in the first one, and when you switch it, it's still pointing towards the x. And then you can really clearly see that those are the same inequality. All right, we do need to graph this one, so really quickly, here's negative 19, a few numbers on either side. Okay. I don't want to include negative 19, but I do want to include all the numbers smaller than that to the left. Okay, and we'll end on one more example. This is a 3-part linear inequality. So we have negative 4 is less than 3 minus 2y is less than or equal to 9. So you can do this in two ways. You could look at each portion of this separately. So you could solve negative 4 is less than 3 minus 2y. And then you could also solve 3 minus 2y is less than or equal to 9. Or you could just solve this all at once with the 3 parts. So I'm going to show you that method. Alright, so you would focus on the part of the inequality that has the variable. If that was more than one part, then you would try to combine like terms. And then we'll just proceed as if we're solving for y in this expression, 3 minus 2y. So the first thing you want to do is any addition or subtraction. So we'll subtract 3. And then we need to subtract from all 3 parts, because remember, if we split this up, the opposite side of the inequality could be either the -4 or the 9. So I'm going to subtract -3 from the -4, and then also from the 9. So then you end up with -7 is less than -2y is less than or equal to 6. And the next step is divide by -2. So that should be a warning. We're dividing by a negative. So right away you need to reverse all of those inequality symbols. So the first one would become a greater than symbol, and the second one would become greater than or equal to. And then go back for the numbers. So here you would have 7/2. In the middle you would have y, and on the right you would have -3. All right, and then the last thing we like to do is usually just reorient this so that the smaller number is on the left. Okay, so it's kind of confusing, like if you say x is between 5 and 1. Okay, there's nothing wrong with saying it this way, but a lot of times we just like to have the smaller number first. It's more natural to say x is between 1 and 5. So I would just flip this entire thing around. So I'm going to start with the -3, then the y, and then put the 7/2 at the other side. And then I want to keep the inequality symbols facing the right direction. So this one between the y and the 7/2 is pointing towards the y. So I want to keep it that way. And then this other one has the pointed smaller end facing towards the -3, so I want to keep it that way. Okay. And then the solution set would be the set of all y such that that inequality is true. Okay, so notice I changed this initial variable to just match whatever I'm talking about in this equation, inequality. All right, and then finally a graph. So we would have a number line, and then I'm going to cheat here. I'm just going to write -3 and then put another 1 for 7/2. Okay, so that's 3.5. I know it's up somewhere past 0. Maybe I'll even put a 0 in here just to be a little more clear. And then we want to put a closed circle on -3. The y could equal that. An open circle on 7/2, and then shade everything in the middle. And that's it. Alright, so from this video, the main idea was how to solve linear inequalities and how to write the solution set using those braces, that set builder notation. So the main procedure there is to just follow all of the rules for solving equations, unless you multiply or divide by a negative, in which case you need to reverse the inequality symbols.